Today we're going to be learning equations of lines, and we're going to be looking at a lot of the same things we just took a quiz on. So we're going to be looking at the slope formula again, but we're going to be looking at some different formulas, all of which you learned in Algebra 1, but maybe it's been a few years since you've seen this, and you haven't used it in a while, so you might forget it. These formulas are all representing the same type of line, a linear line. We will always have a slope for linear lines. Linear lines always are going to be straight lines that have a constant rate of change. These lines are going to cross the y-axis and x-axis somewhere unless they're vertical or horizontal. But there are different forms that we can use to identify these lines. The most common form that we use that you guys saw on the quiz on Friday was slope-intercept form, y equals mx plus b. This next form that we have in 3.4 is actually called point-slope form. So point-slope form is different than slope-intercept. Slope-intercept, if you remember, is y equals mx plus b, where this is your slope and this is your y-intercept. Which it's nice that they call these forms by what they give you. Slope-intercept form gives you the slope and gives you the y-intercept. Point-slope form gives you a point and gives you the slope. So both of these forms both give you the slope, but the forms are different because this gives you the y-intercept, which is a point on the line, but it gives just the number of the y-intercept. Whereas the point in this form is any point that is on the line. It doesn't have to be the y-intercept point. The formula is kind of confusing in that here is what it looks like. It's y minus y1 equals m parenthesis x minus x1. So I'm just going to write this again so I can kind of show you what these things mean. So y minus y1 equals m parenthesis x minus x1. This is the formula for point-slope form. The slope is still this number here. Notice for slope-intercept, the m is the slope. This is still the slope in this form. So the variable still stays the same and still represents the same thing. What's different is that obviously it looks a little bit confusing because we have like subtraction and parentheses, and we have this y1, x1 thing that we're not used to seeing. In this form, we see a y and an x. This form, we see y1 and x1. Well, these numbers are actually just representing the coordinates of the point that you are given. So this right here is the y coordinate of the point, and this number here is the x coordinate. And please write this in your notes. This is the most difficult form, I think, out of the three to understand, because it's just a little confusing. I don't know how you can hear me with music in. So this example up here, now I skipped right to the form. This example up here says, write an equation of the line with slope 4/3 that passes through the point -2, 1. So previously, if I gave this question on like the test on Friday, you would only know how to use slope-intercept form at this point. Slope-intercept form says y equals, and since they give you the point 4/3, we would put 4/3 here, x plus b, and they don't give us the y-intercept, so we would then have to figure out how we could use this point to find the y-intercept. Point-slope form is actually easier to use because if they give you the slope and they give you the y-intercept, if they give you the slope and they give you not the y-intercept, but just a random point, you can put it right into the formula. The formula is just weird. The formula says take y and subtract whatever the y coordinate is. In this point, what number represents the y coordinate? And by that I mean just like the number that's in the y spot.
1.
1. So this would be y minus 1 equals. And then the slope they give you is 4/3. Slope goes right here in this spot, so it would be 4/3 here. Just following the form, then you would use a parenthesis. And then it's x minus, what number does the x coordinate represent? Meaning what number is in the x spot of the ordered pair? Yep, -2. Now this is x minus -2, so if I was to simplify this, minus a negative really is a plus. So the equation in point slope form would be y minus 1 equals 4/3 times x plus 2. And you don't really have to do anything. If you were given the slope and you were given a point, you can just easily put it into point slope form by just replacing the numbers in where they need to go. You need to put the slope in this position right here in front of the parentheses. You have to put the x and y coordinates in these positions here. It's just a little confusing because the point given is -2, 1. And then the 1 goes here, and it looks like it's a -1 because the formula uses subtraction. So these numbers always are going to look the opposite of what they are in the ordered pair. So this says -1, but this is a +1. This says +2, but this is a -2. And that's because the formula is subtraction, which is going to change every number to be the opposite. So in the first example here, it says, write the general form of the equation of the line that passes through these points. So the 2 points that the line crosses through are given here. To create an equation in point slope form, we would first need to find the slope of these 2 points. So finding the slope of these 2 points, we would use the slope formula y2 minus y1 over x2 minus x1. Once we have the slope of these 2 points, then we can use the slope, put it into the formula, and pick a point and put it into the point slope form. So, if this is the first ordered pair, this is x1, this is y1, this is x2, this is y2. Using the formula y2 minus y1, this would be 3 minus 2 on the top. And then x2 minus x1, this would be -2 minus 4 on the bottom. When I go to simplify this, 3 minus 2 is 1. -2 minus 4 is going to be -6. So this slope is -1/6. Okay. So now we have the slope of the 2 points that are given. It's asking us to write this equation of the line. It says the general form of the equation, but we're going to use point slope form because that's what we just went over. So now we have the slope. The next thing we have to do is pick a point. You can use either one of these points. I'm going to show you what it would look like in both. With slope-intercept form, your equations are always going to look the same because every line has a certain slope and it has the same y-intercept. But if we use point slope form, there's infinite points that a line crosses through. So you can all use different points and you still have the right answer. Your equation just might look a little bit different. So, if I change my color and I use green, I'm going to use this point here, 4, 2. If I use this point, 4, 2, and this slope, -1/6, and I put it into this formula here, the formula says take y minus the y-coordinate, which this is the y-coordinate, so it's going to be y minus 2, equals, following the formula, the slope. The slope is -1/6. Parenthesis x minus the x-coordinate, which is this right here. So it's going to be x minus 4. That's if I use that first point given. If I use the point 4, 2, that's what the equation in point slope form looks like. However, if I use the other point, if I use -2, 3, my equation is going to look different. It's going to look different because the point is going to be different, but what will remain the same? The point will be different, but what will remain the same? Sophie? The slope, exactly. So if I now use -2, 3 as my ordered pair, the formula says y minus y1, this is the y1 we're talking about, so it'll be y minus 3, equals, I'm still using the same slope as before because this is the same exact line. And then it's going to be x minus -2, which is really just going to be x plus 2 because minus minus a negative really means a positive. So you have two different answers that are representing the same equation, and they are both correct. If I was to give you a traditional math test and I said create an equation in point-slope form, I would have to accept many different answers because as long as you used a point that's on that line and you put it into the formula correctly, you have the correct answer still. If I ask you for slope-intercept form, though, there's only one answer to that because it will have the same slope as all of the other answers, and then there's only one number that it will cross the y-axis at. Only one ordered pair would represent that number, so you would only have one answer. Point-slope form does differ depending on what point you use. Moving on to other equations of lines. So we kind of started some problems like this, I believe, maybe on the last web assignment. We didn't get some formal notes on these, but there's two different types of lines that we have not really talked about that much yet, besides when we're talking about slope, and that's horizontal lines and vertical lines. So far, whenever we were creating equations, a lot of our lines look, if I was drawing a sketch here, they either look like this, where they were a negative line decreasing from left to right, or a positive line increasing from left to right. We haven't really talked about equations that are horizontal and vertical. So when we have a horizontal lines look like this. All right, so they're straight lines, and we already know from learning about slope that horizontal slopes are what? When a line is flat. So by no slope, what do you mean? What number?
0.
Yes. So it doesn't necessarily have a slope, which I totally understand what you mean by that. Technically, if you put that answer in on a test, it would be wrong because it does have a slope. It's just not going to be any steepness of any sort because the slope is 0. So for horizontal lines, your slope is equal to 0. So if we were thinking back to slope-intercept form, not point slope, which we just learned, whenever you have a 0 slope, 0 would go in place of m right here. And 0 times anything is just 0. So when you multiply the 0 slope times the x value, that whole thing just goes away. And we're left with just y is equal to b. This number here, this b, is technically the y-intercept. So when we look at a horizontal line, the equation of that line is going to be y equals wherever it crosses the y-axis. So in this example, it says y equals 6. If I said that, okay, 1, 2, 3, 4, 5, 6, if I say that 6 is right here, y equals 6, that would be a horizontal line at 6 on the y-axis. So horizontal lines start with y equals. And it's a little confusing because the y-axis is vertical. But when you have an equation that says y equals 6 like this, it does still mean there is a slope there. We just don't write it because 0 times x just cancels it out and it goes away. So all we need to write is just the y equals 6 part. To graph something like this, you would just start at the y-intercept at 6, and when no slope is seen, when you can't see anything with the x, you would know it's a horizontal line. You would just draw a horizontal line at that y-intercept. Vertical lines are the opposite. So vertical lines are going up and down instead of left to right, and we already know that vertical lines have what type of slope?
Undefined.
Yes. So the slope of these are considered undefined. Now the reason why they're undefined is because slope is identifying steepnesses of lines. And these are always going to be represented in ratios, like this number to this number represents how steep this line is. A vertical line is so steep that we can't even put a number to it because the calculator doesn't understand this huge number over something else. Because when you need that second number is going to be 0. And you can't divide by 0 in math because it doesn't exist. So that's why we don't have an actual number for slope that's vertical because it's undefined. So when we have an undefined situation with a vertical line, the equation looks different. Every other line in linear equations usually starts with y equals. If you're looking at slope-intercept form, it would usually start with y equals. And then you would have your slope and you would have your y-intercept. Because vertical lines do not have slopes, technically, their slopes are undefined, they don't exist. It does not start with y equals. It starts with the opposite. It starts with x equals. And it starts with wherever it crosses the x-axis at. So if x equals 5, this is the x-axis right here, this line right here. If x equals 5, if 5 on the x-axis was right here, 1, 2, 3, 4, 5, then x equals 5 would be a vertical line at 5, like that. So these are different because they don't have slopes. They can't start with y equals. So it's kind of the opposite. The x-axis goes like this, but then when you have a vertical line, it's going to be x equals. The y-axis goes like this, but when you have horizontal lines, they start with the y equals. So it can be a little bit confusing. Just remember that horizontal lines have 0 slopes. So in slope-intercept form, it will be y equals 0x plus the y-intercept. That cancels out. You're just left with y equals 6, for example. And then undefined lines, vertical lines, they start with x equals because wherever it crosses the x-axis is what it always is. No matter what y is, this line will always have 5 for its x coordinate. That's why we call this x equals 5. No matter what x is on this line, y is always equal to 6. That's why we call it y equals 6. Does anyone have any questions on that? All right, this is just a refresher from previous year, so this should be okay. All right, so if we move down or we flip the page over to the next side, we have here creating equations through these lines. So I'm going to try A and B with you, or sorry, no, I'm actually going to try A and C with you, and then I'm going to want you guys to do B and D. So we're writing equations for each line. We want to create an equation of a vertical line through the point -2, 4. Some of you, like me, might be visual learners. Like it's helpful for me to just sketch what this point looks like. -2 here is here, 1, 2, 3, 4 is here. So let's say -2, 4 is right here. We want a vertical line going through this point. So I'm just going to sketch a vertical line going through this point so I can kind of identify or see what's going on here. So I can see it's a vertical line visually, even though they told me it was. And because we just talked about what these types of lines are and how they don't have slopes that exist, their slopes are considered undefined, I know that this is not going to start out like y equals. Y equals lines are either going to be horizontal or be some sort of steepness, positive or negative. I know that vertical lines start with x equals. So the equation of this line is going to be x equals, and the number it's equal to is whatever number it crosses the x-axis at. And where is that? -2. This equation is x equals -2. You don't actually have to worry about the 4 at all. The 4 is not even needed other than I use that point to help me visualize what it looks like. No matter what y is, x is always equal to -2. That's why the equation is x equals -2. The second one says, create an equation of the line passing through -2, 3, and 3, 3. Since we just went through point-slope form, let's use point-slope form for these two equations. Point-slope form is y minus y1 equals the slope m, parentheses x minus x1. So, in order to create any equation, we always need the slope of the line that passes through the points. When I go to find the slope of these points, I'm going to first subtract my y values. I'm going to get 3 minus 3 on the top. And then for my x values, I get 3 minus -2 on the bottom. Well, 3 minus 3 is 0. 3 minus -2, 3 plus 2 is 5. It really doesn't even matter because when you divide 0 by anything, it's just going to equal 0 anyway. So I know from looking at this slope that this line looks like what? Is this line vertical or horizontal? Yes, so it's going to be a horizontal line. And this line, horizontal lines, always start with y equals. It has 0 slope, so technically I could, oh, we want to use point slope. Hold on, sorry. Point slope form we can use. If I'm using point slope form, I now have the slope, and now I just pick a point. If I want to use this first point using this point slope formula, I would take the y1 and subtract it from this y here. So using this point, this would be y minus y1 is 3. So it will be y minus 3 equals. My slope is 0. So I'll put 0 here, and then x minus negative 2 would become x plus 2 there. Now, point slope form is kind of funny when you have horizontal lines, because this is a whole bunch of stuff that really we don't have to worry about too much. We could just write it in slope-intercept form. No matter what x is, the y is always going to be equal to 3. We can see it from the 2 points. 3 is in y here, 3 is in y here. So we can also write this equation as just y equals 3 as well. When I told you to use point slope form, I wasn't realizing these two were going to end up being that way. So if you haven't already, take a minute, try B and D on your own, and then we'll go over them. Alright, so going over these problems, we want to create an equation that's horizontal and it passes through 0, 6. So again, it might be helpful for you to draw a sketch. 1, 2, 3, 4, 5, 6. The point 0, 6 would be here. A horizontal line would look like this. And this one is actually easier to do than put in point slope form or whatever. You would just want to remember that it's either going to be y equals or x equals, depending if it's horizontal or vertical. Because this is a horizontal line and it passes through 6 on the y-axis, this equation would be y equals 6. Because no matter what x is, y is always going to be equal to 6. And then the last one there is going to be another weird one, that when I go to find the slope of these 2 points, 3 minus 2 is going to be my numerator, and negative 1 minus negative 1 is my denominator, which ends up being negative 1 plus 1. 3 minus 2 is 1, negative 1 plus 1 is 0. In math, you can never take any number and divide it into nothing. That's like only a magician can do that kind of stuff. When you do divide by 0, you're going to get an error on your calculator. That means that this slope is undefined. Undefined slopes means they are vertical lines. If I was to sketch this really quick, negative 1, 2 would be here. Negative 1, 3 would be here. I could see from looking at these 2 points, they are on a vertical line like this. Vertical lines, instead of using any type of point slope form, vertical lines are always going to start with just x equals wherever it crosses the x-axis at, or like whatever number they share, it's always going to be x is equal to negative 1 like that. All right, and then the last thing we're going to do today is just this problem here about parallel and perpendicular lines, and then we'll call it a day. So the question is asking us to write equations of the lines that pass through the point 3, -2, and are A, parallel, and then B, perpendicular to the line x minus 4y equals 6 as shown in this figure here. So I can see in the figure that this line that's folded out in black is representing, it's a bad picture that I should try to go over, but this line here is representing the equation x minus 4y equals 6. And we want to create an equation that's parallel to this line, so basically the line that's underneath of it is parallel to it. And we also want to create an equation that's perpendicular to it. This line here is perpendicular to it. Before we do any type of parallel or perpendicular stuff, we should first take this equation and make it more user-friendly. What I mean by that is take this equation and put it into a form that we are comfortable using. That form that I like to use all the time is slope-intercept form. Slope-intercept form is any formula that's solved for y. So you just take this formula and you move things around. So instead of it saying x minus 4y equals 6, it starts with y equals. To do that, the first thing I'm going to do is move the x to the other side. I subtract x from both sides. I get -4y equals. I'm going to write the negative x first. So it's truly in slope-intercept form. So that's going to be -4y equals -x plus 6. The last thing I'm going to do is get rid of the -4y so that it just says y equals. What would I do to everything to get rid of that? What would I do to get rid of the -4 in front of y?
Divide.
Yep, so we're going to divide everything by it. Now, it's up to you if you want to just draw like a big division sign like that and just show you're dividing everything by -4. Or maybe it might be more helpful for you to just do everything separately. Divide that by -4 and that by -4. It's up to you and whatever makes the most sense to you. As long as you're dividing everything by -4, I don't care how you do it. This is a -1x divided by -4. -1 divided by -4 is a positive 1/4. So this is going to be 1/4 as our slope in front of x. And then 6 divided by -4. Well, I know this is going to be a negative answer because a positive divided by a negative is a negative. And 6 over 4 is a fraction. I can simplify this to being 3/2. Or if I wanted to just put it in decimal form, this would be -1.5, like that. Or 1.5, or 3/2, it doesn't matter. But I know it's going to be a negative, so it's going to be minus. So this is the equation that they give us. But now this equation is in a more friendly form. This is slope-intercept form. I now know my slope of this line is 1/4. I now know the y-intercept of this line is -1.5. But I actually don't need the y-intercept to determine what we're trying to find. We're trying to find an equation that is parallel to this line, but passes through this point here. So if we look at this blue line is parallel to the black line. And this blue line passes through the point 3, -2. In order to be parallel, lines have to have the same what? This was a test question. In order to be parallel, lines have to have the same what? Anthony?
Is it slope?
Yes. So parallel lines have the same slope. So that means that the blue line has to have the same slope as the black line. What does the black line have as its slope?
1/4.
Yes. So it's going to have the same slope as this, which is 1/4. The problem didn't tell us what type of form to put this equation in. But right now, I know that this line has the slope of 1/4 because it's parallel, and I know it passes through the point 3, -2. The easiest form to use when you're given a point and the slope is point-slope form. So if we use the formula y minus y1 equals slope times x minus x1, we could put this stuff into the formula and be done with it, not have to do anything else. We're going to put negative 2 in for y, 1. So it's going to be y minus negative 2 equals, slope is 1/4, parenthesis, x minus 3. The only thing that I would change about this and make it a little bit more simple is by taking y minus negative 2 and just changing it to y plus 2. This equation is in point slope form, but this equation represents this line in blue that is parallel to the black line because it has the same exact slope, just passes through a different point. Perpendicular lines are different. The perpendicular line that we see here also passes through the point 3, negative 2. So if you see, I just outlined this in green. It also passes through the point 3, negative 2. However, perpendicular slopes have what type of slopes? This is way more difficult than just same slope. Devin?
Opposite reciprocal?
Yes. So they have opposite, also known as negative. The textbook says negative. I prefer opposite. So opposite reciprocal slopes. So the slope of the black line is 1/4. The opposite reciprocal of 1/4 is what? Yes, negative 4. So I know that the slope of this line has to be negative 4. Because it still passes through the same exact point, this stuff here is going to actually look the same. The only thing that's going to be different is the slope. So I'm going to use this point again. It's going to be y minus y1, which is y minus negative 2, which is y plus 2, equals, now instead of using the slope of 1/4, I'll use the slope of negative 4, and then parenthesis x minus 3. And that is your equation in point slope form that is perpendicular to the black line. So that stuff is hard, but the only difference between these two lines is that they have opposite reciprocal slopes. They pass through the same exact point. So tomorrow we'll start with the summary of the equations of